So we've already kind of talked about the fact that the triangle sum, okay, interior angles of a triangle is 180 degrees. The sum of the measures of the interior angles of a triangle are 180 degrees, all right? We're actually going to take a look at something here, okay? So we're going to prove this to be true, okay? So, kind of see how we're going to do that here. So this right here, if you look, okay, this is called a proof. Have you guys seen proofs before ever? No. Okay, so in geometry, we're going to look, again, more at proofs coming up on Monday as well, but here's kind of a proof that's already kind of started for us, okay? So letter D here, it's saying fill in the blanks to complete the proof of the triangle sum theorem. What we did right up here, this little activity, is not exactly a proof. I mean, it's not like, very, I don't want to say professional, but it's just not, we did an argument here, and it's kind of like we convinced ourselves that, yeah, it looks like it should add up to 180, but now we're actually going to prove it's true using some geometry here. Okay, and so letter D again, we're going to fill in these blanks to complete this proof. So you can see there's some blanks here in our little proof. Proofs are very like logical kind of arguments that you make to say something is true. All right, you have these things over here. These are the statements. So these are kind of like your arguments, okay, your points, maybe so to speak, about like okay, how we know these things are going to be true, and the reason is like why we know these things are true. Okay, so this is like our argument, and then our support for how we know those things are true over here. Okay. So here we always start a proof. To do a proof, you always have to start with given information. So here we're just going to be given triangle ABC. So we're just given this triangle ABC, a generic triangle ABC. We want to prove that all of its angles, angle 1, 2, and 3, add up to 180 degrees. All right. So what we're going to do is start out by taking our triangle ABC and drawing a line L that goes through point B and is parallel to AC. All right. So we're going to take that AC, we're going to draw a line L parallel to AC, and it goes through point B, and that's using the parallel postulate there. That's one of Euclid's like rules that you can do. Through any point, okay, you can draw a line parallel to another line there, okay? So we have a line, and then a point not on that line, we can draw a line parallel to this line right here, okay? So, step 2 here says, all right, angle 1, because we have these parallel lines now, angle 1 is going to have to be congruent to what other angle here in this picture? Alex, what do you say? 3. Not necessarily 3. Not necessarily 3. Nope. Think about parallel lines here, right? If AC and line L here are parallel, okay, think about AB as being like a transversal, right? Remember that stuff we talked about, where we talked about like corresponding angles, alternate exterior angles, alternate interior angles here, okay? What other angle must angle 1, and maybe it'll help if I like draw in like another parallel line right here to kind of help you like see. And again, if we like look at this line right here, okay, what angle will angle 1 be congruent with? Yeah, Courtney? Not 2, close though. Eli? Yeah, 4. Is that what you're going to say, 2, Debbie? Yeah, 4, okay. Angle 1 and angle 4 are going to be congruent. What special angle pair are they? Not vertical, they're alternate interior. Alternate interior angles. Shh. Likewise, angle 3 here, okay, so again we have another transversal right here. Angle 3 will be congruent with what other angle? 5. Very good. And again, because these are alternate interior angles, I'm just going to abbreviate that. Okay, alternate interior angles are congruent. Okay? So, angle 4, angle 2, and angle 5 equal 180 degrees. Because if you look at them, right, they make a straight line L here, right? 4, 2, and 5 make a straight line, so they're going to add up. 4 plus 2 plus 5 make 180 degrees, right? They make that straight line right there. So angle addition postulate and the definition of a straight angle, right? 4 plus 2 plus 5 equals 180 degrees. But what did we just say angle 4 was equal to? Angle 1, right? So instead of writing angle 4, I could substitute in angle 1. Here we have the 2 and the 2, and then what is 5 the same as?
3.
We just said it was the same as 3, didn't we? And so we just did that by the substitution property, right? We substituted in. So that's our reason for why we can do what we just did there. That's the substitution property. And look what we've got. Angle 1 plus angle 2 plus angle 3 is 180 degrees. All right, those 3 interior angles of the triangle add up to 180 degrees. We just proved it to be true using only the fact that we start with the triangle ABC and using other stuff that we know to be true as well. Okay, so we've now proved it. That's true for any triangle we're going to run across. All three angles add up to 180 degrees. All right, so if we turn the page here, when we turn the page here, you're going to see there's other formulas too. We're going to come back to that. So you'll see here we talk about interior angles of other polygons. So for example, there is a sum for a quadrilateral, there's a sum for a pentagon, a hexagon, a heptagon, and an octagon. We're going to look at those later at a separate unit, okay, so we'll come back to that. But if you turn the page once more there on page 317, okay, page 317, we're going to also look at this page as well. Let me see here, do we have? No. Okay, no real good practice for that, darn. Okay. So, in addition to all the angles adding up to 180 degrees, we have another theorem as well here. It's called the exterior angle. Okay, so if you look here, when you have a triangle, all right, if you take one side of a triangle and you extend it, all right, that extended side creates an angle with another one of the sides of the triangle right here, right? So you extend the side and it creates this exterior angle. Now, why do you think we call that an exterior angle? Outside the triangle, exactly right. It's exterior to the triangle, it's outside. So again, it says an exterior angle is an angle formed by one side of a polygon, in this case our triangle here, and the extension of an adjacent side. So one side and an extension of the adjacent side, that creates this exterior angle. Okay? And then we also have two remote interior angles here. So these are remote interior, okay, so the word remote means like far away, right? So these are the two interior angles that are far away from that exterior angle. Here's like, this is an interior angle as well. It's not near to it though, it's not far, it's near, so we don't really name that. But we name these two the remote interior angles because they're kind of far away, okay? So, first of all, this exterior angle right here and this interior angle, how will those two angles be related? How will this angle right here and this angle right here be related? How should they be related? They'll be supplementary, exactly right. They're add to 180. It creates a straight line. So exactly right, Eric, okay? Now, there's also a relationship, though, between the exterior angle and these two remote interior angles, okay? And we're going to look at that right now to see that. All right, so you can see we've drawn a picture drawn right here, all right? And we're numbered our angles 1, 2, 3, and 4. 4 is an exterior angle, 3 is an interior angle, and then 1 and 2 are the remote interior angles to that exterior angle. Okay, so step 1, it says to use a straight edge to draw those things, but we already have it drawn, so we're just going to go ahead and just use that. All right. Step 2 here says you know the sum of the measures of the interior angles of a triangle, that is 1 plus 2 plus 3, has to equal what? 180, right? Oh, it's already got the degree symbol there. So that's got to equal 180 degrees. So 1 plus 2 plus 3 has to equal 180. Since, as Eric just said, since an exterior angle is supplementary to its adjacent interior angle. Okay, so that's a lot of words right there I just threw at you. So an exterior angle, so for example 4, is supplementary to its adjacent interior angle. So the adjacent interior angle here is 3. Remember, 3, adjacent means next to. So these two angles are adjacent to each other. We also know that angle 3 plus angle 4 is going to equal what? 180, like Eric just said, right? So now if you look here, 1 plus 2 plus 3 is equal to 180. 3 plus 4 is equal to 180. So what can I say about 1 plus 2 plus 3 and 3 plus 4? What must be true about these two things? They're both equal to 180, so they must also equal each other. They must equal each other. So in other words, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal the measure of angle 3 plus the measure of angle 4, right? These three things add up to 180 all the time. 3 and 4 will always add up to 180. So that means those two things must be equal to each other. Okay? So you might be like, okay, Ms. Wimar, that is like really complicated. Why the heck are we writing this down? Well, this equation here, what can we do? There's something in common to both sides, isn't there? A measure of angle 3. And what can I do to both sides of an equation? I can subtract the same thing from both sides, right? Well, I can subtract the measure of angle 3 from both sides to cancel it out. And so then I'm left with the measure of angle 1 plus the measure of angle 2 is equal to what? Measure of angle 4. Exactly right, okay? And that's our concluding kind of statement there. So we just use a little bit of algebra to show a new relationship in our triangle here. Okay, so let's look back at our picture and see what the result of this is. We just said that 1 plus 2 has to equal 4. So here's 4, the exterior angle. Here's 1 and 2, the two remote interiors. So if you look, these two angles have to add up to make this exterior angle here. The two remote interiors, right, remote, they're far away. These two remote interior angles add up to make angle 4. Okay? And so we're not going to actually do the proof of that because I feel like we just pretty much proved it right there. I'm not going to worry about that. Okay? And so there's the theorem right there. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So for example here, angle 4 is going to equal angle 1 plus angle 2. Okay? Let's turn the page here, and yes, we have some examples of that, okay? All right, so if we look here at number 9, for example. Okay, sorry, on the next page. Okay, number 9 says, determine the measure of each exterior angle. Okay, determine the measure of each exterior angle, and then it says to add them. We won't worry about adding them just yet, but we'll talk about that. Well, I guess we can add them later, okay, but right now. So let's determine the measure of each exterior angle. So for example, let's try and find the measure of this one right here. Okay? So remember we just said that an exterior angle, the exterior angle here 4, was equal to the sum of its two remote interiors, 1 and 2. So if I go back to here, okay, this exterior angle is going to be the sum of what two angles here? 60 and 40. Yeah, these are the two remote interiors. So this one's going to be 60 degrees plus 40 degrees, which is equal to what? 100. So this angle is 100 degrees. Okay, so that exterior angle right there is 100 degrees. All right. Let's see here. What else can we figure out? What about, let's see here. If I want to find the measure of this exterior angle, I need to know, well, I got the 60 right here, but I also need to know the measure of this interior angle too. What's that one going to be, though? Debbie?
80.
Yeah, 80, okay. So, Eric, how'd you figure that out, that this one has to be 80?
Because there's supplementary with the 100.
Yeah, if this exterior angle is 100 degrees, this angle together with the 100 has to add to 180. So, yeah, this 180 minus 100, bless you, leaves us with 80 degrees. There's another way, too. What kind of shape is this right here? A triangle. And what do the three angles in a triangle have to add up to?
180.
180. So, Eli?
So that's how I got it the first time. We just added the 60 and 40, got 100, the other angle has to be 80.
Exactly right. So two different ways to do this here. All the angles in a triangle have to add up to 180. If you know two of the angles, subtract them off of 180. So 180 minus 60 minus 40 gives you 80 degrees. And so there, that is 80 degrees. So that means this exterior angle right here is going to be 60 plus 80, 140. Or alternatively, maybe Eric would probably do it this way. If you see this as a 40-degree angle, this angle is going to be supplementary to it, so you can do 180 minus 40, and it gives you the 140 there too. So two different ways to go about doing the same thing there. All right, and what about this last exterior angle here? It's going to be 80 plus 40, 120. Okay. So there's that exterior angle right there, and there's that exterior angle. Okay. Now, here is an interesting, so we found all three exterior angles of this triangle, 100, 140, 120. And they add to what? What? That's right, okay? It says add them together, what can you say about their sum? And yes, all three of these angles, 100 plus 120 plus 140 equals 360 degrees. Now, is that a coincidence, you think? Yeah, maybe, maybe not, okay? We'll actually find out later on that this is not a coincidence, that the sum of the exterior angles of any polygon will always add up to 360 degrees. So any triangle you draw, if you find all three exterior angles of those triangles, it'll add to 360, okay? So, all right. So there's that. Let's actually look at some like algebra and stuff like that then here, okay? So now we're going to apply the exterior angles theorem to solve problems with unknown angle measures by writing and solving equations. All right, so for example here, letter A, okay, I'm going to zoom in on this real good. We'll do 2, I'll do 2, and then you guys will try 2 here, and then we'll get started on the assignment. All right, hopefully we'll have time there. Yeah, we should. Well, I mean, I'll just have you do 1. Anyway, measure of angle B, okay? We want to find the measure of angle B. So if you look here, we have a picture, okay, with some relationships. I have an exterior angle here, 145. I have the 2 remote interior angles here, 2z and 5z minus 2, okay? Remember, we just got done saying over here that the exterior angle is equal to the sum of the 2 remote interiors. So here, my exterior angle 145 should equal the sum of the 2 remote interiors. So I'm just going to say 145 equals 2z plus 5z minus 2. Okay? You can include the degree symbols if you want or not. I'm not going to include the degree symbols until the very end when I'm going to give the angle measure there. Okay? So again, exterior angle equals the sum of the 2 remote interiors there. Okay? Questions so far on any of this? We're all okay there? All right, so to solve this equation, all right, to solve our equation here, what are we going to do? Let's see. Oh, right, is that the bathroom? No. Okay, let's go to... great, awesome. Mitchell, to solve this equation, what should we do now?
Add variables.
Yep, so 2z plus 5z is 7z minus 2. Good. And then what? Add 2 to both sides. Good. 147 equals 7z. And then what? Divide by 7. And so we get z equals 21. Yeah, very good. Okay, so the answer here is 21.
Would it be 5?
No, Mr. Wood. Yeah, it's 5 times 21. Yeah, exactly right. Guys, I was trying to find angle B here, not z. I want angle B. So angle B is 5 times z minus 2. So it's 5 times 21 minus 2. Okay, so that's 105 minus 2, which is 103 degrees. And there's, whoops, sorry, it's off the screen. There you go. So you have to do 5 times the 21 minus 2 to equal the 103 degrees there. Okay, good. Thank you, Mitchell. All right. Let's go to letter, any questions on letter A there? Okay. Let's go to letter B. And I'll probably just, well, yeah, we'll see here. Maybe I'll have you guys try one. Okay. All right, so Jake. All right. I got an exterior angle here. Okay, 3x minus 8 degrees. I have 2 remote interiors. This symbol right here, Jake, means what? So that means what measure is it? Yeah, so I'm going to go ahead and just mark that, 90 degrees. And then this is x plus 2 degrees. We want to find the measure of angle PRS. So means I got to figure out what x is. So I need to set up some sort of equation here. So using that exterior angle theorem, what could we set up as our equation here? Okay, careful. 3x minus 8 is going to equal something, but it's not just equal to 90. It's equal to the sum of the remote interior angles. So it'll be 90 what? The sum means to do what? Add the 2 remote interior angles. So 90 is one of the remote interior angles. What's the other remote interior angle? X plus 2. So we have 90 plus x plus 2 there to set that equation up. Okay? So that makes sense there, Jake? You see that now? Exterior angle, 3x minus 8, has to equal the sum of the 2 remote interior angles, 90 and the x plus 2 added together. Okay? All right, cool. All right, let's go to Josh. Aww. Okay, can we simplify this left-hand side at all, Josh? Nope. How about the right-hand side here? Any like terms? Yeah, what? Yeah, so 90 plus 2 is 92. Okay, I'm going to have to like write it over some here because I'm going to run out of space. So we're ending with x plus 92 then. All right, now Josh, I have variables on both sides, so I got to get rid of one of those, right? So which one do you want to get rid of? Yeah, good. I like subtracting the smaller of the two. Great. Okay, so that's gone. I'm left with 92 over here, right? 3x take away an x is 2x minus 8. Okay, and now what, Josh? Continue solving for me here. What do we got to do? Add 8. You got it. I get 2x equals 100, and then what? Divide by 2. So x is 50. All right. Is that my answer, Josh? No. What do I still have to do? Plug it back in here. PRS, 3 times 50 minus 8. So 3 times 50 is 150. Minus 8 is 142 degrees. So that is our final answer there. That's the measure of that angle, PRS. Okay, that's the measure of our angle PRS there. Okay? Yeah, PRS, that's the actual measure of the angle there once we've solved it out and stuff like that. 100.
Why wouldn't you just do just the angle PRS, or just no matter?
No, you're, okay.
I guess.
Alright, if you figure out what your question is, let me know. Okay, I mean, you asked some good questions. I don't want to, like, you know, not answer them. Okay? Alright, so I think I'm just going to go ahead and let you guys get started on your assignment. That way, you know, you can get to work, get some work done here for it. So, alright, here we go. Let's take a look here. Alright, so we're going to start on page 320. We're going to jump around a little bit because we skipped a little bit of the section. But on page 320, we're going to do numbers 5. Let's see here. And then we're going to skip over to 11, 12. Okay. And then 13, 14. So I guess 11 through 15, let's say. How about that? I'll just make it easier here. And that's to page 322. Okay? Homework tasks? No, not really. Some people wish there were because they don't do their homework assignment and then they don't get points for the day.